Hi, this is Politicus Magnus, and today I'm here with a very strange sounding question. Could fossil fuels go 100% green? And why does that sound like a silly question? Obviously, when we think about green energy, we don't tend to think about fossil fuels. We tend to think about fossil fuels as being the thing we're trying to replace. And that makes sense, but some new experiments and actual projects that apparently work have kind of come out, and it's looking really like we could continue to use fossil fuels with zero emissions. And I know that sounds crazy, but there's a lot of energy in fossil fuels. It powers most of what humans do on the Earth right now. Of course, producing all this carbon dioxide and so forth that everybody wants to get rid of. Um, so, if we could continue to use them as an energy source without pollution, without any pollution, hopefully, and some of these projects that are working, like I said, do claim and appear to not produce any pollution. So, given the other options, wind, solar, bioenergy, new hydroelectric, different types of nuclear, why would we potentially anticipate that this green fossil fuel energy would continue in the market? And there's two main reasons, which I'll get into. I mean, basically, it comes down to price and just the sheer volume of energy stored, the amount of energy stored in the form of fossil fuels that are accessible as it is now. But yeah, in comparison to other potential factors, there are some reasons why we would expect maybe that this technology would continue to progress and would continue to be a major power source for humanity in a way that doesn't produce the sort of ecological impacts that are possible. And so one of the reasons is, like I said, the two reasons I gave, but let's compare. So you've got, your basic renewable resources. You're talking about, solar panels and wind turbines, both of which in many of the projects that they've been used on have turned out to be not so great. A lot of these, solar panel farms and wind farms tend to apparently sort of fold and go belly up. The maintenance appears to be too high many times, and just costs of replacement parts and things like that. The other problems, of course, with wind and solar is you need rare earth metals, you need rare metals and rare earths, and there's dirty production of different components. You also have the issue of rarer materials that can only be mined in certain places, like in Africa, where a lot of these rarer metals are mined by children, potentially slave labor. So there's all sorts of real big problems with the renewables in general for now. There's the bioenergy field, which is, it's very good for rural areas, I think. I think there's a lot of potential for reusing a lot of products of farming for energy, and I think that's a good idea to produce. You can produce energy locally with local materials, biomass, and so forth. But for large scale, it doesn't really add up because of the massive amount of mass of biomass that you need. It also would contribute to factory farming and that kind of environmental disruption based on how much land usage to grow this or that, fuel crop. We already do this with corn, the whole ethanol, additive in gasoline from corn, and that turned out to be pretty big disaster, frankly. It was supposed to reduce emissions. It really hasn't. It was supposed to do a lot of things. What it really did was really mess with the market for these farmers, and especially corn farmers and so on. So there was a lot of problems with that. But bioenergy is viable in certain ways, but I don't think for mass scale. Same thing with renewables. There have been problems, at least right now. Now, I'm not going to discount technology. My entire point is that it's technology that's going to save us from whatever anthropogenic pollutants that we might produce and cause any sort of ecological harm. Other options, new hydroelectric. There's been a lot of studies that show that old hydroelectric is actually probably okay because it's already outgassed. But new hydro, apparently, because you have to make a large reservoir at some point, that tends to cause vegetative matter to rot in the water, which produces a large amount of methane because it rots anaerobically. And so it looks like hydroelectric actually negates its own carbon emission reduction through the production of methane gas for a long time. So it pretty much equalizes out. It doesn't actually really, at least new hydroelectric, like I said, not necessarily the old ones that are already there. Nuclear, there's a lot of stuff going on in nuclear. I think there's a lot of potential for the technology there. You've got, half of the major countries in the world are investigating thorium. The United States has had thorium, had a thorium reactor back in the 60s, I believe, and then it was at Oak Ridge at a military facility, and the generals wanted bomb fuel, and so they shut that reactor down, but it worked just fine. And there's a bunch of countries looking to commercialize that. There's newer pebble bed reactors, which use basically ceramic-coated uranium pellets, and those can't melt down. Physically, they can't. Same thing with the thorium reactor. It cannot melt down. And the good thing about thorium is also that it cannot produce nuclear weapons fuel. And the nuclear waste is actually, it's only radioactive, seriously, for a couple hundred years rather than tens of thousands, which is actually a big deal. We can actually dispose of it in a safe way, that we can ensure that it will be safe for the amount of time that is necessary for it to cool off, which is not true with the uranium reactors that we have now in general. And so fusion is actually, it's coming along. That new helix, it's not a TACMAC, but the new helix reactor that they developed in Germany is actually almost at the break-even point, which is great. It's great, but it's not there. It's not producing more energy than it uses. So, it's feasible. It's likely we will get to that point where we can use fusion, but it's not here yet, right? So what do we have right now, right? Not much other than fossil fuels in terms of stuff that's ready to go. Nuclear for sure, but again, the modern nuclear plants, we're working on better ones that can't melt down, can't produce nuclear bomb material, and also produce like the thorium reactors waste that's much better than the waste from the current reactors in that way that I discussed, amount of time, the half-life. Or potentially, if we get fusion that produces net energy, zero waste, helium gas. Well, not zero. I mean, you got to throw away the shielding, which is neutron bombarded, big time, pretty highly radioactive with some really weird radiation coming off of it that you don't want to mess with. But it's nothing compared to now, and the amount of waste is so small. Even if it lasts a long time, we can bury it in the depths of the earth pretty easily. It's not a lot of waste, whereas now we have a lot. That's frankly just sitting around. We don't even have a place to bury it. It's just sitting in all the reactors, which is a bad thing. So this is sort of my argument why this could go toward fossil fuels, as at least in the near future, at least one of the main, if not the main, sources of actual green energy, 100%, zero carbon emission green energy, could actually come from fossil fuels for a certain amount of time. So I've got two links to two articles. I'm not quite sure what this Inc.com is, but the article is well written. I've read some other articles on it. This one just was written very well, and I can confirm that everything that they wrote in there is exactly what I read other places. So the other one's physics.org, and so that one, I chose that article specifically because it's physics.org, but again, it's the same information in many articles about this company. So the first one is a company called Net Power, and they have apparently figured out how to run a gas power plant, a natural gas power plant down in Texas with zero carbon emissions. They capture 100% of the carbon dioxide produced by the plant. And apparently right now it can power something like 5,000 homes, that test plant, but they're working on building much bigger ones, in the higher megawatt, area, it could be a big deal. And that's the first one. So if we could use natural gas still, but without any emissions, that'd be great, because it's a great source of energy and we've been using it more and more. And the other one is a company up in Canada, up in Calgary in Canada. And they're working with the University of Calgary as well. And they figured out a way, and this is some crazy stuff, to extract hydrogen gas, only hydrogen gas, from oil fields. They basically are doing a system that chemically burns the oil underground. Now, it's not burning underground. It's not on fire because it's at such high pressure, blah, blah, blah. It's technically burning, but it's oxidizing, we'll say. And so they can pump up hydrogen gas from that process. Everything happens underground, and all the carbon stays under the ground. Only the hydrogen comes up. That's amazing. They have a zero pollution hydrogen gas extraction plant that is running right now as well, just like the other the gas plant we're talking about. That is running right now, and it's producing hydrogen gas only. And it injects steam, oxygenated hot water steam. Completely environmentally neutral, completely no problem. It's not coming up out of the ground. They use like nanofilters. I'll get into it. So let's start with the first one. So this is the net power. I'm going to read from this article a little bit. I'm going to skip some parts, and I'll say when I am. So the article says, in the Texas city of La Porte, about 30 miles outside of Houston, the power plant of the future generates enough electricity to power 5,000 homes simultaneously, and it burns old-fashioned fossil fuels, and yet it produces no carbon emissions. Sound impossible? Well, yeah, it sounded impossible, but apparently not. So, Net Power, the Durham, North Carolina-based startup behind the plant, is on a mission to prove it's not only possible, but also a potential solution to one of the biggest contributors to climate change. If all goes well, the plant will be the first of many like it around the globe. And I'll skip a little bit. While carbon capture and storage is scientifically plausible, the process usually is prohibitively expensive. First, it requires the construction of extra facilities for capturing carbon. Then, once those facilities are built, they use so much power that they end up offsetting many of the environmental benefits they're designed to achieve. British chemical engineer Rodney Allam might have found a way to change that. In the late 2000s, a group led by former Morgan Stanley managing director Bill Brown formed 8 Rivers, a venture capital firm that incubates startups working on solutions to large-scale problems. First on the firm's list, energy. Soon an old classmate of Brown's pointed him in Allam's direction. The two set up a meeting in London. Rodney had some ideas, Brown says. Pretty quickly, we knew we had our guy. Allam developed a new fuel burning process that entails capturing carbon dioxide at the combustion stage. He joined 8 Rivers, which teamed up with 2 large companies, engineering firm McDermott International and energy company Exelon Generation, which invested a combined $150 million to create and fund Net Power, the startup company. The process that makes Net Power so innovative, now dubbed the Allam cycle, allows much of the carbon dioxide released during combustion to be recycled. The carbon that isn't reused is captured. It can then be injected underground, where it's permanently absorbed by rock or sold to companies that can use it for other purposes like manufacturing plastics or extracting oil. And I believe that when they use it for extracting oil, they pump the CO2 down into the ground to displace the oil and force it to the surface, and whereby the CO2 stays underground and gets absorbed, and so it stays in there. The net result is an emission-free process that can generate electricity on a large scale, obviously using natural gas. The Texas plant, which first fired up in May, can produce 25 megawatts. That's quite a lot. Enough to power all the homes in a medium-sized town simultaneously. It isn't yet sending electricity to the local grid. Brown hopes that will happen within the next several months once the plant completes an extensive series of tests and gets connected with Texas utility company ERCOT. Meanwhile, the company is looking to partner with an energy company on its first full-size plant, which will be capable of producing 12 times as much energy. Net Power's goal is to complete that project by 2022. I think this article is a little bit older, so some of this stuff they might be sending to the grid already. I'd have to look. Skipping a bit here. We've got to make a cheaper than polluting system, Brown says. Here in the U.S., we tend to think that if we can afford it, then the system works. But that's not good enough. We've got to make it so cheap that China and India will choose it. and developing nations will be able to afford it. It's an ambitious goal, but a worthwhile one. Electricity generation is the cause of about 40% of the world's annual greenhouse gas emissions. So almost half, minus 10%. So there's a lot more to the article. Criticisms, people complaining that it still burns gas and so forth. And of course, gas a lot of times comes from fracking, and maybe they have a problem with fracking. But still, this is a major step in the right direction. We can make fracking better too. We can make it not pollute as well, right? Of course, the companies claim that it doesn't already, but we can try to make it better either way. So that's their complaints. They're sort of complaining, but screw those people, because this is a really, really good thing, which I'll maybe get into some more why, but I think it's kind of obvious why. The next one is an article about proton technology. This is the phys.org article, and this is really cool stuff, really high-tech stuff. So here's the article. Scientists have developed a large-scale, economical method to extract hydrogen from oil sands, or natural butamen, and oil fields. I'm going to skip a bit to talk about hydrogen vehicles and stuff, and how this is a good idea. The process can extract hydrogen from existing oil sand reservoirs, with huge existing supplies found in Canada and Venezuela. Interestingly, this process can be applied to mainstream oil fields, so regular ones, causing them to produce hydrogen instead of oil. That is a big deal right there. That's the ticket. Bingo. So our oil fields could simply produce hydrogen, which we can use in cars that we've already developed. We, humans, that is. Science. We already have things that can use this, so we can just use the oil fields to produce hydrogen? Wow. Oil fields, even abandoned oil fields, still contain significant amounts of oil. The researchers have found that injecting oxygen into the fields raises the temperature and liberates hydrogen gas, which can then be separated from other gases via specialized filters. Hydrogen is not pre-existing in the reservoirs, but pumping oxygen means that the reaction to form hydrogen can take place. Grant Strem, CEO of Proton Technologies, which is commercializing the process, says, this technique can draw up huge quantities of hydrogen while leaving the carbon in the ground. Wow. When working at production level, we anticipate we will be able to use the existing infrastructure and distribution chains to produce H2, hydrogen gas, for between 10 and 50 cents per kilo. This means it potentially costs a fraction of gasoline for equivalent output. That's crazy. That is crazy. This compares with current hydrogen production costs of around $2 per kilo. Around 5% of the hydrogen produced then powers the oxygen production plant. So the system more than pays for itself. That was kind of a non sequitur there. It compares with the production costs. Okay, but then it kind of says, it goes to another thing. It says around 5% of the hydrogen produced then goes back into the plant. So the plant itself uses 5% of the hydrogen. Of course, when you burn hydrogen, you produce just plain old water, which is really nice. Clean water, too, actually. Pure water. So, yeah, once again, this is really big news. This is crazy. Huge, huge, huge news. So I'm going to skip a little bit, again, and talk about some other stuff. What comes out of the ground is hydrogen gas, so we don't have the huge above-ground purification costs associated with oil refining. We use the ground as our reaction vessel. Just taking Alberta as an example, we have the potential to supply Canada's entire electricity requirement for 330 years. Jesus. So skip a bit. The only product of this process is hydrogen, meaning that the technology is effectively pollution and emission free. All the other gases remain in the ground because they cannot go through the hydrogen filter and get up to the surface. Wow. So it goes on about how they're working with the University of Calgary. But this plant has also already been built and is already in operation and is already selling hydrogen gas. It is, of course, a prototype plant, but it's working. That's, it works, and they're at scale. They're doing it on an oil field. They already have the plant running. They're already selling hydrogen gas. They're working with the university. They're working with the local government. It's working. I don't see how it can fail right now, just based on what's going on already, what they've already done and proved. So those two in particular, I just wanted to highlight. Otherwise, if I keep going, I'm sure there's other things, but I don't want it to be too long, the video. But yeah, those two things in particular, wow. The hydrogen thing even more so for the future in general, once we start doing hydrogen cars and stuff. But we can do the other one right now. Well, we can do both of them right now, but we need everybody to get hydrogen cars and and whatnot in order to take advantage, the full advantage of what Proton Technologies has developed there. Very strange. As difficult as it is to conceive of green fossil fuels, it appears that science allows us to extract energy from these dirty sources, and with zero emissions. So, and in some cases, zero pollution at all, altogether. So I've said for a long time, basically, that technology is the only way out of the problem of anthropogenic environmental impact, which, of course, is inevitable, but we can reduce it and we can potentially even eliminate it. And here we've got two examples of total elimination of that emission, which everybody says is so important. Like I said, I'd also say methane as well is a big deal for that. Probably potentially more of a big deal. But so yeah, the problem is, electric cars have problems because of battery storage capacity. Hydrogen cars had a problem due to requiring the hydrogen gas. And so they each had their problems, but now we're looking at, hey, hybrid hydrogen electric, plenty of hydrogen gas, cheaper than gasoline. Man, that could be a revolution, So yeah, 100% zero emission method of extracting hydrogen from even old oil fields could basically change the automotive landscape completely, as the price for the gas plunges, and apparently below the price of gasoline. Probably because it doesn't have to be refined. It's just hydrogen gas. It's what you need to power those fuel cells. Yeah, so, and then the second one we can do right now, and they're doing it right now, and they're building a bigger plant already. Large-scale powering of homes and businesses is a major problem. The scale is the problem. And in terms of pollution and emissions, again, 40% of greenhouse gas emissions, that could be zero with natural gas, which we have plenty of, and we've been getting more and more of. Whether you like how we get it or not, compared to what we're doing right now, this is unbelievably better. This ends the problem if we could implement this very quickly. Pretty much. It's slow it down big time and all that. So natural gas has been a really simple and pretty much one of the most entropy efficient methods, with many stations even powered by methane outgassing from old garbage landfills. I know where there is one. It powers quite a few homes, about 1,000, I think. Just from an old landfill, and the gas comes up because it outgasses the methane, and instead of just burning it off, they burn it and produce electricity. That one's not clean, of course. That's just a regular one, but it could be. It could be made to be 100% clean, too. So we can recycle our garbage into energy without any net emission. That'd be amazing as well. Of course, it's a small source, but very convenient if you're living next to an old covered up garbage dump. You can get it right there and not have to transport. So that's cool. That's why they did it there. Or that's why they do that. So with zero emission methane power stations, natural gas power stations, we could even turn our garbage dumps into a carbon negative source of energy. Wow. Again, that won't be a big source, but still cool. So maybe we shouldn't count fossil fuels out yet. In the race to find the most efficient and lowest cost zero-emission source of energy, as strange as it may sound. And, that's kind of the weirdness of science. It's impossible to predict just what kind of technologies might be invented in the near term, in the far term. We have no idea what we don't know, what we can do, what kind of fuels we can actually use. In this case, it's always a shock and surprise to find out what's actually possible with technology, and we don't know what the technology is going to be. And looking at this technology, it does change the game. It changes the landscape of future energy sources that we can count on and make sure that they're green. They're not producing the bad stuff that our current systems produce. I've got a lot of hope for nuclear in terms of thorium, and also potentially fusion. They're getting close. I don't have a lot of hope in the near term anyways, really for the renewables as much. But it looks like at least these two new technologies that can extract energy from fossil fuels with zero emissions and in one case, I guess, no pollution at all. it seems to me in the near term that might be one of the best options that we can go for right away, because these things are apparently already working. And that's heads and tails above a lot of the renewable stuff and a lot of the high-tech stuff that we're still working on. Not that we shouldn't work on that as well, for sure. But solving the problem as soon as possible is what everybody says they want to do. And if we can do that with fossil fuels without the emissions, that would just be unbelievable.